Hi girls, here are the problems you asked for from REvSet22B. We're going to start with number 5. All right, and here it is on the left. Number 5. If a number is subtracted from its square, the result is 20. So if a number, that means we're going to assign a number, if a number is subtracted from, so it's being subtracted from, which means you've got to take it away from something in front of it, right? Like that. Its square, its own square, so x squared. So it's x squared minus x. The result is an equal sign, 20. And then it's basically saying, hey, let's take that, and then what is the number? X squared minus x equals 20. So that's our equation to work with, okay? We can solve this algebraically by bringing everything to one side, so subtract 20 from both sides. And then I end up with this equation, x squared minus x minus 20 equals 0. And then I can factor, I can PSF this. And if I product sum factor, I'm going to end up with two different expressions here, right? My product is negative 20, my sum is negative 1, my factors are going to be negative 5 and positive 4. So x minus 5, x plus 4, right? So each of these, null factor law, set equal to 0. Therefore, x equals positive 5 and x equals negative 4. Those are my two values. Now, the other thing I can do is I can take, oopsie, let's change this. I can take this equation and put it into my calculator, and I'm going to see how that works. So watch. X squared minus x minus 20. Ready? Y equals x squared minus x minus 20. And I save that. And I want you to notice my two intersecting points here are negative 4 and 5. And those are the same answers, 5 and negative 4. Do you see that? Negative 4 right here and 5 right here. Okay? The other thing I can do that also works, so I'm giving you 3 ways to solve this, is you can graph, the left side of this and the right side of this as two separate equations. So we can take out our calculator and we can graph y of x equals x squared minus x and y of x equals 20, okay? Graph both of these and let's see what happens. So I'm going to go back here. I'm going to take this off and I'm going to graph x squared minus x, and I'm going to graph also y of x equals 20. And now we're going to look for the intersections of these two lines here with this, and notice how they intersect at 5 and negative 4. Again, the exact same answers that we got both by graphing the equation once we rewrite it algebraically, right? The negative 4 and the 5 here. Or you can graph the two equations and find their intersecting points and what are x values. Or you can do it algebraically, but sometimes you cannot do it algebraically. So resorting to algebraic is, being able to do algebraic solving is important, but you need to also always know how to do the calculator version. Okay? So that's number 5. Now let's talk about number 7. And number 7 is like many of the problems we did in class today. What we're going to do is take the formula given for this ball bouncing, okay? And we're going to put it in. So y of x equals, and I'm going to put in 1 plus 21t, and I'm going to use x instead of t, minus 3t squared, and again I'm going to use x for my t, and I'm going to graph that. All right, so have a look. This is the bouncing ball. Now I'm going to change my zoom here to make sure I can see the whole graph, so I can see everything from here all the way over to here. Okay, that's the whole arc of the ball. Now, what is the ball at height of 30? When is the ball at a height of 31 meters? Again, we've got time here and we've got height here. So at 31 meters. So I can do this a couple ways. I can zoom into 31 meters and figure out when is it at 31 meters? Well, it's at 31 meters not just once, but twice. It's at 31 meters here and here, isn't it? So it's at 31 meters at 2 seconds and 5 seconds. On the way up at 2 seconds, on the way down at 5 seconds, okay? The other way we can do that, if you want to just do this and say, oh, how about I just want to know, I want to know what it is at 31 meters. So 31, y equals 31, and hey, now I can use my intersections and notice that it says at 2 seconds, that's my x there, and again here at 5 seconds is my other x, right? 2 and 5, same answers at 2 seconds and at 5 seconds. Now, when is the ball at a height of 1 meter above the ground? Same thing. I can put in an equation and just say, hey, y equals 1. When is it 1? Well, I've got to find the 1 now though, right? When is it at 1? It's at 1. And again, I can use my intersections. Well, at 0, that's where it starts. So it's being hit from a height of 1 meter to begin, and at 7 seconds. So at the beginning, that's its starting point, x is 0, and here, x is 7. So those are my two answers for number 7. Let's look at 8b, okay? So here's 8b. 3 to the power of 2x minus 1 equals 1 over 3. Remember, this is really important, right? Both sides of the equation need to be rewritten with the same base. Now in this case, they kind of have the same base, right? The challenge though is that this one is in the denominator and that's not going to work for us. So we're going to have to do some rewriting of this one to make sure that the 3, the base of 3 with an exponent, is in the numerator. So to bring it up, this is originally a 3 to the power of 1, right? So we bring it up, you make it a 3 to the negative 1. So I'm going to rewrite this, and I'm going to keep my left side of 3 is 2x to the power of 2x minus 1 equals, and on the right, 3 to the negative 1. Once we have the same base, we can equate as in set equal to each other. We can equate the indices. We can equate the exponents. We can say and write an equation just using the exponent parts, right? So we're going to write an equation with those. So 2x minus 1 equals negative 1. And now I can solve for my variable. I'm going to solve for x by adding 1 to both sides. 2x equals, shucks, 0. So x equals 0. Okay? That's 8b. Last but not least, you guys asked me to do number 10. So let's do number 10. Now, number 10 says use a graphics calculator to solve. So what we're going to do is we're going to take this. Now, again, if you have x cubed and 1 over x, remember one of the solutions from the previous problem? I'm going to show it to you here. Remember this, the purple highlighting, where I graphed this, the left side of the equation, and then I graphed the right side of the equation separately and then found the intersections? That's what we're going to do with this, okay? So we're going to graph both of those. So the two things I'm going to do to graph is I'm going to graph, oopsie, let's use the right color ink, y equals x cubed, and I'm going to graph y equals 1 over x. Those are the two things I'm putting into my graphing calculator. So let's do that. Let's take off the ones we don't need anymore. And let's add. I'm going to start with y of x equals x cubed, x to the power of 3. That's one of them, and that's going to be hard to see, so we'll change that color. And then, let's pick a nice green, good. And now we're going to also graph y of x equals 1 over x, so it's going to be 1 divided by x. And that's going to be a good color. I'm going to get myself into a good place where I can see everything. Okay, so here we go. That's cool, right? If I zoom out, it's kind of an asymptote thing going on, and we've also got the equation that's got the cube in it. Looks like this. That's a standard shape. And I have two intersecting points here and here. So all I care about, and you could sketch this as it asks, but all I care about, again, is what are the x values of these 2 points where they intersect. Well, x is 1 here and -1 here. So that's my answer. X equals -1 and x equals +1. That's it. I hope this is helpful. Be sure you also review the answer key from the assessment that we did yesterday. And I will see you in extra help and in class on Friday. Take care, girls.